In this video I'm going to illustrate how a set of data files can be processed using toolbar buttons. The toolbar buttons that I will use are the Add Regions, the Propagate and Match, and I will use a menu item which is Select All Matching Blocks. CasaXPS displays data using two panes. There's the right hand side and the left hand side. The right hand side displays the logical structure of the data file and allows a selection of VAMAS blocks. The left hand side allows the display of data. So to begin this analysis, I will load using the open option on the file menu, and I'm going to make a multiple selection of VAMAS files. I'm holding the control key down as I make these selections, and so all four of these files are now selected, which I can say open, and the files are open. I can close the empty VAMAS file, which will help me to tile the data files that are now open. So we can see here we've got four data files. Each one of these data files represents a different experiment on a nickel oxide, and these experiments represent sputtering the surface with ions, and the species vary. I've got a helium or I've got an argon species, and the energy of these ions differs between these data files. But other than that, the experiments are identical in terms of the definition. I'm now going to choose one of these files and start the preparation of the profile. And the element transitions of interest are the carbon 2p and the oxygen 1s. And what I would like to do is create a set of regions for each one of these different element transitions. We have carbon 1s, nickel 2p and oxygen 1s, and I can make a selection of all the equivalent VAMAS blocks in all these files simply by using the select and match all blocks. So here I'm able to select the VAMAS blocks that I'm going to work on, and this will be true of all of the files, as you can see. So we'll go back to the full page view. I wish to create the regions using this Add Regions button. So I just clicked the button, I made a selection, and I have now a set of regions defined. The default settings were the last default settings that I used, for example the Shirley background or the average width, and so each one of these have been defined for the different element transitions based on these default settings appropriate, in the sense that the relative sensitivity factor has been brought in from the element library for each one of these, and that's because these have correctly assigned element transition fields for the VAMAS blocks. So the element library and the VAMAS blocks agree, hence we're able to extract the relative sensitivity factors. All that remains now is to make some adjustments to these regions so that we are confident that they are going to be representative of the various signal. I make the selection I'm interested in performing the transfer. That's a mistake, because what I want to do is arrange these data in such a way that I can then propagate from these regions to all the other files. And in order to do that, I need to arrange in the active tile the three different VAMAS blocks with regions defined. Then I can make the selection. So in each one of these files I now have a selection. I have the three spectra with regions defined in a state that when I make a selection of this particular display tile with the three spectra overlaid, then I can apply the propagate and match. And what this allows me to do is, all I want to do is transfer regions from these three using the match option, which means that the source contains carbon, nitrogen and oxygen, and any VAMAS block that matches with these source fields will then accept a region from this set of three on the basis of the element transition field. So carbon will go to carbon, nickel will go to nickel, and oxygen will go to oxygen when I have the match species transition field enabled. So pressing the OK button, and we look at any one of these files, we will now see that we have regions defined that are appropriate for analyzing these data.